Good morning, everybody. My name is Adama, and I'm a PhD student from Dakar, Senegal, and France. And I will present a part of my project, which is the impact and alternative of environmental pollution at Hann Bay, Dakar, Senegal. The bay is located in the Dakar region of Senegal, which is in West Africa country. And it's 15 kilometers long. And the bay is characterized by a strategic location. There is more than 80% of industry which is located there. And those industry through their wastewater discharges into the bay without prior treatment. In the bay, we have a population, the population increase in 1.72% per year. So the population are very young, and it's characterized by a high unemployment rate. Also, we have a limitation in the wastewater treatment plant in our country. So all this lead us to a very solid and industrial waste discharges into the bay, like you can see here. And all this is causing by the uncontrolled anthropogenic pollution, like I said, the fisheries or the industry discharges. And we noticed significant pollution like a petroleum product or nitrogen or heavy metals. So 20 years ago, the bay was the second most sumptuous bay in the worldwide after Rio de Janeiro. And the environment is characterized by impact. The environment is characterized by a very toxic contaminants due to pathogens and smelly odors. These nauseating odors is caused by the sulfate-reducing bacteria. Which we call it SRB2. They are responsible in multiple reduction, such as sulfate to sulfide, and can metabolize a large number of organic carbonates. And they are living in environmental, anaerobic environments. So for our project, we have 3 objectives. First one, we want to look the physical and chemical characterization into the bay. And after that, the second part is lead to the sulfate-reducing bacteria isolation. And after, we want to use this strain for see their impact in the bio-remediations. So for the material and method, we use dissolved organic matter to characterize the DOM, dissolved organic matter, which is significant bioavailable organic carbon. And they affect the biochemical process because they play a critical role in a nutrient transport in the aquatic ecosystem. So we characterize these dissolved organic matter with fluorescence using fluoromax fluorescence spectrometer, and the analysis was made in Toulon. After the DOM characterization, we also characterize the trace metal contaminant because we were interested to see the anthropogenic activities when the industry free or discharge these sewage, the heavy metals can be detected, and the heavy metals can be accumulated in the sediment and in the fisheries present in the bay. So we was interested to look the trace metal contamination and use two indicators like enrichment factor and geoaccumulation index to assess the environmental effect of the human activities. Doing it by ECP-OS instruments. So for the isolation of sulfate-reducing bacteria, we made a lot of microbial enrichment and use a prefabricated media specific to sulfate-reducing bacteria. We use a screening of salinity and temperature to select the chosen one, and after that we isolate. When we isolate the chosen one, we make a solid media to extract the colony we want using an anaerobic chamber. At this step, just one colony is taken and purified, and we use this colony to go further the molecular analysis using DNA extraction and sequencing with Illumina-Seq and going to data processing, like you can see. So regarding the result, a parallel factor analysis is used to isolate the underlying fluorescence component present in DOM for the EEMS, means emission and extraction wavelengths matrix. To understand the nature of the DOM, mean the bioavailability and the propensity to form disaffection for byproduct and mercury methylation, Chang and Weil proposed to divide those wavelengths, like showing here, to 5 regions. And for our works, we was interested to soluble microbial products in the 40 regions. So for the trace metal contaminant, this result is currently in the article redaction. So we just show us the study of the literature from DIOP and al. In 2017, which show that the anthropogenic activities have a real impact in the metals. So in here we can say our sampling point was made in the source of the pollution. Mr. Diop and al. Made all their sampling point in the estuaries and the coastal zone. So we expect, I think, worse result about that regarding the trace metal contaminant. From SRB isolation and characterization, we choose, our choice was based on morphological characteristics, growth rates, and H2H productions. And for the DNA extraction isolated, we compare our strain or our species with the known species already described in the internet. So this is an example of SRB strain we isolate from our result. And this one is Oleodesulfo vibrio alaskensis. And here are some strains described in the literature, and the blue one is some example of our strain isolated. So we can see that we can use it for mineralization of organic water or for degradation of rich protein. To conclude, we will focus on a tracer of biological component, heavy metals, and some genus like Marie-desulfovibrio, Oleo-desulfovibrio, and desulfovibrio, isolated at Yarach. Yarach was the point reputed the most polluted area in the bay. For the outlook, we want to see that using those strains, see the degradation of hydrocarbon in the bay, and propose an innovative biodepollution produced using the strain. So from the ecological disaster, you can see in the picture, to this one, we think it's possible with Anbe restoration. Thank you for your attention. And I would like also to thank Hervé Macari and his team